Hi everyone, and welcome to our next tutorial. In this example here, we're going to take a look at a parallel circuit. So when this switch is closed here, S1, what will happen is if we follow conventional current current will flow in this direction here and get to the point right here where some of the current will travel down this branch, some of the current will travel down this branch. That current will all come back together and will eventually come back to the battery through A3. So if I know that the current is 9 amps flowing through A3, and if I know that resistor R1 is equal to resistor R2 is equal to resistor R3. So for example, if I know that the current here is, or the resistance is 2 ohms, and the resistance here is 2 ohms, and the resistance here is 2 ohms. What happens is down this branch here, it sees a total resistance of 2 ohms. But going down this branch, it sees these two together. So it sees a total resistance of 4 ohms going in this direction here. So this branch here has twice as much resistance as this branch here. Even though I don't know what this voltage is for my DC source, I do know that in total I have 9 amps. So what does that mean? Current travels through the path of least resistance. This branch here has twice as much resistance as this one. So what that means is this branch here will have 6 amps of current flowing down through it. So this ammeter will measure 6 amps of current. This one here going this way will only have 3 amps. Because there's twice as much resistance going down here. So 3 amps will go through this part of the circuit. When the current meets up at this point right here, the two currents will add together following Kirchhoff's current rule, so that 9 amps will enter back in to the DC source and 9 amps will leave that battery. So even though I didn't know what the battery voltage is, I knew if the total amount of current was 9 amps and I knew the resistor values here, 6 amps will go through A1, 3 amps will only go through A2. That's it for this tutorial. Take care. We'll talk to you soon.